Okay, so we'll move on to the next part, which is about token optimization, which can help us control costs. We'll see how prompt engineering can help us optimize on this as well while maintaining the retrieval quality. Now, understanding token costs is important because otherwise you might end up building an application which is extremely expensive. Um, to just illustrate this with an example, let's say you are using the model GPT-4o. The input price for 1 million tokens is $2.50 and output is about $10 for a million tokens. On the other hand, if you see 4o mini, GPT-4o mini, it costs about 15 cents for a million tokens for input and 60 cents for output. So GPT-4o mini is 16 times cheaper than GPT-4o, but it is not the best model in terms of reasoning. So when do you use which model, that makes a big difference in terms of cost and also in terms of the quality. So with your difference per month at a certain scale would be, let's say, $9,300 per month versus $570 per month, depending on which one do you use. Now, this is based on certain estimations that are given, and we'll look at an illustration as well. But how do we optimize this? Now, uh, here's a sample on how, let's say, this optimization could work by model routing. So when you have some basic support answers where you already have something in your documents and your chunking and your RAG pipeline is robust enough to give you the relevant information, you can use the mini model because it already has the details. It just has to articulate it better and send across the response. Second bit is conversation summarization. Again, when we have a longer chat and we want to summarize the past messages, we can use Mini because it again has to do reframing of the conversation. Same for groundedness check. If we want to compare uh, the answers, are they uh, in line with what we are expecting, then we can use this. But when we have complex tasks are which require some reasoning or some analysis, we use the better model or the reasoning model, which is GPT-4o. In this case, uh, the complexity is higher, maybe the stakes are higher, and the accuracy might be worth the cost that we pay. Now we'll see this with an example. So I just have a simple Python code here to do the calculation. So if we estimate 4,000 conversations every day with 5 messages per conversation, that means we have 4,000 into 5, 20,000 API calls in a day. And these are our average token sizes. And these are the two models that we are using. So just to illustrate this with an example. Yes, our daily cost will be $310 using GPT-4o, which is 9,300 a month. And cost per conversation is about 8 cents versus 550 odd dollars for GPT-4o mini. So this is obviously we can change this based on the actual values that we estimate, but this cost difference will be significant. And in this video, we'll see how we optimize this. Now to see this in practice, I've added a few lines to our existing function, which tells us how many tokens were used and multiplies it with the cost that is incurred. So we'll just run the same sample conversation again, and we'll look at the costs that each API call we are incurring, the cost that we're incurring with each API call. So it's the same questions. Here we can see with every question, now we have the input tokens, output tokens being printed and the estimated cost as well. So as you can see, it is less than a cent for each conversation, but all of this would add up to a few cents in every single conversation. So when you have the conversation volume, which is pretty high, this can escalate pretty quickly. Here we are looking at a simple example of a normal prompt versus an optimized prompt. So a normal prompt is, let's say, something on the top that we have here, which could be verbose, something like you are a customer support agent for your desk, a project management tool answer the customer's questions based only on the provided documentation. If documentation doesn't contain the answers, say I don't have the information, be concise and helpful. You should be professional but friendly. Do not make up information. do not reference information outside documentation, and so on. If the question requires account-specific information, you don't have access to escalate to a human agent. Always respond in the structured JSON format. Include a confidence score if the confidence is below 0.5. Set escalate to true. So this is, let's say, a normal prompt which is giving instructions in the way you would do to a human, which is not needed. So there are a lot of redundancies in this. Now here, if you see some of these pointers that are highlighted on the right side, a lot of this information is already covered in the first line. Some of the information or this instruction about not taking or providing information which is not in the documentation comes for the third time. Some of these things uh, you don't need to explain in the prompt. For example, if the customer seems frustrated, acknowledge this and so on. So uh, you can just set temperature to 0 to handle some of these things. One other instruction given is to always respond in the JSON format, which doesn't need to be a prompt now because we're using structured outputs anyway. So a more concise version of this prompt is given at the bottom. So here it is just 3 lines. It says clear desk support agent, answer only from the provided documentation. If the answer isn't in the docs, escalate, be concise, and set confidence below 0.5, and escalate equal to true when unsure. So this is the simple prompt that is needed. But from a token perspective, you will see this is 147 tokens, the one at the top. The one at the bottom is about 40 tokens. So when you look at the difference of 147 and 40 tokens for a month, you will see that you save about $160 just by changing the prompt from this verbose or the unoptimized prompt to a more optimized prompt. So this is one of the first ways in which you can optimize your token consumption. Another quick win is on how the summary, context, and the system instructions are sent in the API call. This is because OpenAI caches your prompts. So if your beginning of the prompt is identical to one of your previous prompts, you get a discount of 50% on the tokens. So the cache works if you have the beginning of your prompt same as your previous prompt. Now, in this case, if this is the case, if you send your system instructions at the beginning of the prompt, which always remains the same, you will always save 50% of the token cost for these because this is cached. And below that, you can send the information about the retrieved documents, which may or may not be the same, and conversation summary, which almost always will not be the same. So if you follow this structure, you save on the cost for the top part, the system instructions. And if you don't follow this order, you miss out on this discount by maybe putting the conversation summary on the top or retrieve documents on the top and not putting the system instructions on the top. So again, with this and the optimized prompts, you can actually save more money on larger volumes of API calls. Moving on, we'll look at some ways of improving the retrieval quality. So there are certain patterns that we would notice when working with RAG pipelines. First one is wrong chunks being picked up. It is possible that some chunks might be close to each other, but may not be relevant. For example, somebody asks about a billing question, but something on cancellation or vice versa might come up. Although they are related to the account subscription somehow, but they may not be relevant to the user's query. Second failure mode is contradicting chunks. You could have multiple chunks giving contradicting information. Maybe there are older documents which are still available in the vector database and so on, which gives us information. For example, the limit for a file, one document could say 100 MB, the other could say 50 MB, and they might be on two different chunks for maybe two different features, but you might have this contradicting information. Then you could have missing chunks because the user query did not match them properly. So relevant chunks exist in a knowledge base, but they don't get picked up because the score is too low. For example, some user asks about SSO, and the knowledge base has something in the lines of SAML-based single sign-on, and the embeddings uh, are not able to match both the user query and the chunk available. And you could also have scattered chunks. So you could have queries which return uh, unrelated chunks. So somebody might say help with an account, and this could bring up chunks which are not related to the account management bit, but from different parts of the platform. So these are some possible failure modes, and we look at ways on how we can address some of these with some advanced techniques. We'll not spend too much time on it, but we'll just touch upon some of these uh, methods. So there are four techniques, and this is just an illustration on how it can improve your retrieval and your responses. For example, baseline, the way currently we have seen everything work, your score might be 0.82, where your top correct chunk comes up 14 out of 20 times. Failure rate is 6 out of 20. Then by adding something called threshold tuning, which we'll see, where we put a minimum threshold on relevance, uh, we may still not be able to get the correct answer more, but our failure reduces, and the escalation to, let's say, a human agent can be, let's say, more streamlined and more clean in this manner. And you can still answer or maybe improve your customer satisfaction by connecting them with the agent when the the AI is not able to answer their queries. There is some. The next method is hybrid search, which has PM25 with something called as alpha blending. PM25 means best match 25, which is a way of identifying the top 25 words which are close to your query. And there's another uh, blend or another way where you well, or the LLM tries to find the meaning behind those words and not exactly those words. For example, in our case, if it is SSO, maybe there are 25 words that are related to it, and one of them actually leads to SML-based single sign-on, understanding the meaning of it and not maybe just a direct correlation. So that is a blended approach. It's a little bit more technical. We'll not go more into it, but that's another approach which can help you get better chunks as results, and that can help you improve your correct responses, let's say from 14 out of 20 to 16 out of 20 times, and your failure rate reduces even further. The next approach is called re-ranking, where we use a cheaper or a lighter model to identify chunks which are relevant out of maybe a bigger set which has been retrieved. For example, we retrieve 5 chunks and we ask another model to identify which are the top 2 or 3 chunks that are relevant. So from the 5, we actually just use 2 or 3, uh, which the second model identifies. So that way we are re-ranking the chunks that we get. This can again improve your score from, let's say, 16 out of 20 to 18 out of 20, uh, and your failure rate reduces further. The fourth one and the last one on our list is query expansion. When a user asks something like help with my account, uh, you can actually expand this query to uh, maybe multiple queries, something like help get my subscription information, help me with my billing, help me with uh, the limits related to my account, and maybe a couple of other related topics if you want to. And then you can run hybrid search on them, re-rank them again, and then provide the response based on these expanded queries and chunks received for each one of them. So this way you are reducing the chances of missing out maybe some important aspects of the query which you may not have considered initially. Now we will just very quickly go over how this code looks like for improving the retrieval quality with all the techniques that we just discussed. This is the base level which we were using till now on retrieving chunks. Next, let's say the threshold tuning is where we add a minimum score. So any chunk which has a score of less than zero point 0.8 will be excluded, and responses will not be generated based on those. This is a simple uh, if condition or a match condition where if the score is only if the score is greater than zero point 0.8 will it be taken in. Next, we have the hybrid search where for PM225 we have rank PM25 as a package, and this can be used to uh, you can use this directly in your RAG pipeline and identify chunks, so the top 25 chunks, and then process it further. You also have a re-ranking where once you generate the chunks, you send it to ChatGPT or GPT-4o-mini with a temperature 0 with this prompt where it says rank these chunks by relevance, return only the indices of the top n number of comma separated values, most relevant first, chunks, and then you pass on the chunks text. You're also passing the user query on the top here. So we have the code here, and I'll share this all of this code on my GitHub repo, which is linked below. I'll just run this to showcase how this actually works. And for this, I have just created a slightly more complex user query about creating a project level dashboard for risks from multiple projects into a single dashboard and asking how do I do this. So if, as you can see here, this is the original query that I asked. Can I create a new report or get data where I can have project level risks in a single dashboard? So this got expanded into 3 topics as we had discussed. We are still tracking the tokens and estimating the cost. You will get a response with a relatively high confidence. And in this case, the answer is to create a report that includes these. You can use custom reports feature, which is available only in the enterprise plan. This feature allows you to build and share reports using any task and custom fields, and you can include risk-related fields in your report to have a comprehensive view. So it gives you the answer which is correct based on this query expansion and all these methods that we saw for improving the retrieval quality. So that's pretty much it for this video. We'll next look at how to make it